Hello, this is Dr. Gary Hawkins with the University of Georgia Crop and Soil Science Department and UGA Extension. Today we'll be demonstrating how to use the water and wastewater Enviroscape model. Funding for this video has been in part from Georgia's EPD 319 program. Today we want to cover the drinking water side of our Enviroscape wastewater and water treatment model, which is on the right side over here in our city. And I'm going to remove the two city buildings just for a better view. And we'll just go ahead and remove the factory as well just to get it out of the way. First, we want to take the covers off of the water treatment plant and the water tower off of the model. Now you can leave them on if you want to, especially the water tower, until we get to some of the water running through here. But I'm going to go ahead and remove them for our demonstration. We're also going to take off this long street, and we'll take off the short street as well. The purpose of these streets is to show that a lot of the pipes are kept underground. On this model, the blue represents the water lines and the clear is the wastewater lines. So in this video, we're going to focus on our blue lines and how we treat the water that will be pumped through these pipes. First, we need to put some water in our system. So first, I'll put some water in our channel and fill it up, the channel up itself. If you're in North Georgia, for instance, and in most cases North Georgians get their drinking water from rivers or creeks, so that's what we're going to look at first, and then we'll look at South Georgia and where they're getting their water from and how the process is a little different. So as we start this process, there's a small syringe. I'm using a larger syringe here, but there's a smaller one that comes with your kit. Pull some of the water from with the small syringe. This would indicate a pump in the creek, a lake, a reservoir, or wherever you get water from. We would then put that water in the number 1 slot here in our water treatment plant. The number 1 slot here is really just a settling basin, a coagulation basin, or a flocculation basin in a normal water treatment plant. At this point, and I won't do it today, but there's a coagulant in your kit that you can use in the system. This coagulant is just a chemical, a polymer, an alum, or some other material. This coagulant helps the sediment, the bacteria, and anything that would be in your creek, river, or lake water start coming together to form large particles and settle out. As we put more water in the system, you will see it flows into the number 2 basin here, our clarification basin. Again, you could add a bit more of the coagulant that's in the kit at this point. The coagulant in the kit is gelatin, so it would coagulate like gelatin would and start forming a mat. This is where we put in the coagulant in a normal water treatment plant, so this material would start flocculating in basins 1 and 2. As we put more water in the treatment plant, it would run into the basin 3. This is where a lot of that material would actually settle out or be settled out. As basin number 3 fills up, it will act as a chlorination basin, and we'll use red dye to represent that chlorine in this case, though in the kit it is actually blue dye, but we'll be using red so it's easier to see. As we add more water, it runs through basins 1, basins 2, and basin 3. That chlorine then goes into basin 4. On this model, basin 4 is our dechlorination basin. So at this point, we add chemicals to dechlorinate it. We don't want chlorine or some of the breakdown residuals in the chlorine process killing the bacteria and other organisms found in our water system. We don't want to get those harmful residuals into the water line, so we add dechlorination chemical. At this point, there is a plug here that separates the treatment facility from the water tower. We will remove this plug and let the clean water from the dechlorination tank flow into the water tower for storage. Today I'll go ahead and fill our water tank with clean water. This is like any water tank that you can see. It can be ground-based or it can be elevated and acts as a reserve water source. Water tanks are actually at the highest point in the landscape to provide a constant pressure for our water system and keep the water flowing into our buildings. So if we want water for our house to drink, to use it for cooking, for bathing, for flushing the toilet, etc. As we turn on the faucet, the water would actually come out of the water tank, flow down into the channel, and I'm not sure if you can see it in the video, but it actually flows into our house. The same process occurs for the buildings we remove in our city. That water would flow down the channel, down the water pipes into our cities. Again, the purpose of our water tank here is to provide a constant pressure so we can push water when we need to be. This can also be used by the fire hydrant system that can be linked to the same tower or anything that requires the need for water reserve. So that's the urban side of the water treatment and distribution. Now let's look at the rural side. If we're looking at the rural area, we don't have a water treatment plant per se, as rural homes and country homes may be isolated or too far away from the city. These homes typically get water from a well. A well is a hole typically 4 to 6 inches in diameter that is drilled down into an aquifer to get water, with an aquifer system being any water-bearing formation. You can see a picture of what a typical construction of a well looks like here in this picture. When creating these wells, you may have to drill through whatever material are in the way of your aquifer. If you're in North Georgia or in the mountainous areas, you might have to drill through crystalline rock to get down to the water. If you're in South Georgia or more in the coastal plain area, you would drill down into a sandstone or limestone to get your aquifer system. As we drill the well down into the aquifer, we get the water source that we need. In Georgia, there are multiple different aquifer systems. In South Georgia, we have the Floridan and the Claiborne aquifer systems, mainly south of the Macon area. North of Macon, we have more of a crystalline rock structure, so putting wells in these aquifers is where we get water up north. Once you have the well, it just needs the pump to bring the water to the surface. The pump can then pump water to the house. To represent this pump system with Enviroscape, we use a spray nozzle, and underneath the cover here is a reservoir of water. The spray nozzle represents the pump that you would use to get the water from the aquifer system, which is represented by the water underneath the cover on the model. Since this well water is typically not treated, you can have a small treatment system in your home. Due to the possibility of pollution from multiple different sources, it's a good thing to have your water tested at least annually through your UGA Extension service or some other source. With that, this is the water treatment side, and in another video we'll look at the wastewater side of this model. This has been Dr. Gary Hawkins with University of Georgia and UGA Extension. Thank you.